All right, so lesson 5.3, which is what we're doing today, is about solving rates. Now, there's going to be something a little bit different here that you're not used to, so you're going to have to pay attention and take notes. It's that simple. Okay, everybody okay with ratios? Yes? Okay, with ratios, there is no labels, right? Okay, it's kind of like the same thing. Okay, when we're dealing with rates, there is two different quantities, right? There's a different label on top and a different label on the bottom. Okay, today we're going to be canceling those labels out. That's the hard part to kind of wrap your head around. Okay, this isn't extremely difficult, but sometimes the questions can have multi steps, and it gets a little interesting. All right, there is a formula that you have to know. And I don't know if you've dealt with this in science or not, but you need to write this down. Okay. That would be the distance formula. Distance is equal to rate times time. D is equal to RT. Okay. D stands for distance. R stands for rate. T stands for time. Okay, so if memory serves me right, this is like a combination of lesson 1.5, right? That's a formula, right? So when you read the problem, all you got to do is plug it in, right? And solve. Okay, along with that, chapter 1, right? Anytime you have a variable next to a number or a variable next to a variable, that means to, anybody? Multiply, right? So you're going to be multiplying R and T here. Okay. So that we're all on the same page, because we're going to have to do a different formula here down the road in a couple minutes. These all have to do with distance. This is the distance formula. Okay, you got to determine whether you're trying to find the distance or the rate. Okay, because there's a different rate formula that we'll show you here in a couple minutes. So again, as I always try to give you a heads up and tell you, you got to read carefully. All right, whether you're finding distance or whether you're finding rate. Okay, but right now, we're going to find distance. All right, everybody good? All right, first one. Let's see here. I'll write the problem out for you. Maybe. Come on. Why is this not working? All right, let's do this. All right, I'll read that to you because you may not be able to. It says a falcon can dive at a speed of 80 meters per second. How far can it dive in 4 seconds? Okay, so hopefully something up there you're thinking, well, the first thing you should be thinking is how far, that's a distance thing, right? Okay, so right now, and again, we're only dealing with this at the moment, but they're going to be mixed up for you. That's the formula that you need, right? You're trying to find the distance. So you need to find the rate and the time that it takes this falcon to do whatever it needs to do, right? Okay, so if you haven't noticed yet, there is no word rate up there, is there? And there isn't, right? Well, that's why I want to box this in right here. Speed is another word for rate. So anytime that you see the word speed, they're telling you the rate. Okay? And if you watch those video, if you watch that video in the folder, not my YouTube video, but the other one, it did a really good job of any time that they used the word per. Not only was it a rate, but it was a unit rate. Hopefully, you're watching those as well. Okay, everybody good so far? All right, so we're trying to find the distance, right? So we don't know what that is. The rate is 80 meters per second. So we need to write that as a rate. 80 meters per every 1 second. Okay, that is the R right there that we just put in the formula. Let me change colors here. This is the R. That's the rate. Not only is it a rate, but it's a unit rate. Why is it a unit rate? Because it has a 1 in the denominator. That's correct. Okay. All right. We're going to multiply that. Now this is where it gets a little bit different for you mathematically. Okay, the time, how long does it take the falcon to do that? Well, it tells us it takes him 4 seconds, right? So 4 seconds. Now that's not a rate. Okay, that is a whole number, right? 4 seconds. You agree? Okay, now that looks kind of funny in the math world. What did we say we normally do to a whole number to make it look like a fraction? Masa, you remember? Oh, Brady, sorry. Put a 1 under it. That's right. Put a 1 under it. Okay, there's no label on it. There's no label. It just looks better because now it looks like we have 2 fractions that we are comparing. We're not comparing them. Okay, so far so good, right? Now, this is where you got to ask yourself, if I'm trying to find distance, which label up there is associated with distance? Meters. That is correct, right? Do we care about seconds? We do not care about seconds, but watch how this works. Because mathematically, you just can't go, okay, it doesn't have anything to do with seconds, so I'm not going to use it. You can't do that. That's part of the problem. Okay, so what you do here is, as long as and this is where it's going to be important later on here, you need to get your labels diagonal from each other. It's almost like cross-reducing. See how you have seconds that are diagonal from each other? As long as they are diagonal, you are crossing off the seconds, not the numbers. You need the numbers, but you're crossing off the label that we don't need. Okay, the labels cannot be side by side and cross them out. You can't do that. As long as they are diagonal, think of cross reducing. Okay, you can cross reduce labels out, right? Which is what we just did. You can also cross reduce numbers. Okay, so as long as that's the case, we have 80 times 4 gives us 320. 1 times 1 gives us 1, right? So now we can say that that falcon, how far can it dive in 4 seconds? 320 meters. You gotta have a label on these. Okay, you can't just write 320 because who knows? Do you mean seconds, feet, miles? What do you mean? Okay, it's no different than rates. We're solving rates, so you have to have a label on your answer. So far, so good. Everybody good? All right, we're going to keep this same problem. We're just going to tweak it here for a minute. Okay, I'm not going to rewrite it. So let's say that that falcon still dives 80 meters, right, in that same 1 second. And now it wants to know how far it can go in 7.5 seconds. Okay, this is where we can change the problem to anything that we want. Okay, 4 seconds, 15 seconds, 7 and Mr. Fisher, I don't know what to do. It's 7.5 seconds. Okay, everything still stays the same. Nothing changes. We're still trying to find distance, right? So we still plugged in. I don't know why that works. There you go. Okay, so now we got to take 80 times 7.5 and multiply that together. Right? When you do that, you get 600. I'll do the math for you. Okay, 1 times 1. Remember, these are no different than fractions. You're multiplying straight across. 1, right? So the distance of our falcon here in 7.5 seconds is going to go 600 meters. Does that make sense, right? Can travel a little bit longer, right? He's got more time. So far, so good. Okay. All right. Different question. How high does the hot air balloon rise in 15 seconds? Bless you. Are we still trying to find distance? Yes? Yeah, yes, we are. How high does the hot air balloon rise? Right? From the ground up, that's distance. Okay? So we're still using this. Now, hopefully, you're asking yourself something. What are you asking yourself? Do you have enough information? No, you do not. What do you need? You need you need the rate. Now, what you don't see is in your book, there's a picture of a balloon. Okay, and over on the right over here, there's a picture of a balloon. Okay, and underneath it, it says it rises 9 meters every 3 seconds. Okay, it rises 9 meters every 3 seconds. Okay, once again, you need to take a look at the pictures, okay, in the book. All right. So if we have that, then we have our rate of 9 meters every 3. Oops, that's not a 3. Every 3 seconds. And they want to know how much it will rise in 15 seconds. So here we go, 15 seconds. Now, you don't have to put a 1 under it. I do. Most mathematicians do. It just cleans it up. It makes it look neater. It makes it look like if you take away the labels, you are comparing two fractions. Okay? Does that make sense? All right, so here we go. Anything you notice that we might be able to do? Jason? Okay, so this is one, very good, sir. This is one way that we can do this. If you recognize the rate, right? This is what Grayson was talking about. If you can recognize the rate that we can make it into a unit rate. Holy cow, what is going on there? Oh boy. All right. There we go. Okay, if you can make it into a unit rate, you can make it into a unit rate. That's fine. Just don't forget the label. Okay, and over here there's nothing that we can simplify over here. We make that the same, right? Okay, so if we do that, then now we can cross off the seconds. This is an important part, folks. Don't forget that. This is like one of the most important parts in solving rates. You got to cancel out the label. That label is not needed. Okay, because if you're trying to find distance and you give me two labels, guess what? It's wrong. It doesn't make sense. You got to have a distance label. Okay, that means that you didn't set it up correctly. Okay, so if we multiply across, we get 45 over 1, right? Because 1 times 1 is 1. 3 times 15 is 45, right? And there we get distance is equal to our 45 meters.
Cross reduce, does it only work for seconds? Or does it work for any other way?
Okay, I'm glad you said that because that was my next one. Grayson found out that I'm glad that he said what he said because that was the unit rate way. Okay, so to Kahan's point, right? So we have 9 meters. We'll set this back up. It's the same problem. Over 3 seconds. And we still have the 15 seconds here. Okay, you can't cross reduce this way because the 1 and the 9, right? Anytime you get a 1, there's no sense cross reducing, right? Okay, can we cross reduce this way? Absolutely we can. If you see that, right? How many times does 3 go into 15? That would be 5. 3 goes into 3 one time. Okay, there's nothing wrong with that. Okay, so I wanted to show you both. That's why I'm doing this problem. I wanted to show you both ways. Some of you may recognize, hey, the rate, I can turn it into a unit rate, which is fantastic. You're going to get the same answer. If you don't recognize that, and I can cross reduce, right? Not only the seconds, but the numbers, that works as well, right? Because now we take 9 times 5, we get 45. 1 times 1 is 1. And again, we're left with the distance is still 45 meters. Okay, there's no sense, to Kahan, to your point, there's no sense cross reducing when you got a 1 because it's still going to be the same, right? All right, everybody good with that? Mason, did you have a question? You had your hand up. You good? All right, everybody good with the distance formula? Are you sure? No, well, no. The label needs to be a distance of something, right? So when you make sure, right, that's a good question. So when you finally solve it, don't just put D is equal to 45, because 45 what? Your label, if you're solving for distance, has to be a label of something of distance. Miles, feet, inches, something that you can measure, right? Seconds is not a label of distance. Minutes is not a label of distance. Does that make sense? Okay, that's why it's important to cross off those labels. Does that make sense? Okay. All right, so now we're moving on. All of these have to do with speed or rates. Oh, I don't want to write speeds. Now, I don't want to get into too much algebra here and getting your hamster all tied up in your noggin there. At later, I'll show you how this works. But our rate formula is rate is equal to distance divided by time. You're going to need to know that one as well. Okay, so it all goes back to the beginning. You're going to have to read the question carefully. Which formula am I going to use? Am I trying to find distance, or am I trying to find the rate of something? Okay, the good news is we're not dealing with the time the time formula just yet. Okay. All right. A great white shark swims 90 feet in 2.5 seconds. What is its speed? So once again, they don't like to use the word rate. They like to substitute in the word speed. So obviously you got to know that. Okay, now this is actually easier in the sense of setting it up than the distance formula. Okay, and what I mean by that is the rate already makes itself, right? What's the distance? 90 feet, right? What's the time it takes them to go 90 feet? 2.5 seconds. Now, the math is a little bit harder, but the setup is easier. So now you got to go back to chapter 3, and you now have to divide 90 divided by 2.5. So now you got to remember how to divide by decimal. Okay, so this is where you would do a little bit of side math. Now, your answer here has to have how many labels? What are you trying to find? Trying to find a rate, right? How many answers were on your labels in 5-2? How many labels did you have to have for a rate? You had to have 2, right? They're already there for you, feet and seconds, right? So when you divide this out for this great white shark, you get 36 feet per every 1 second. Okay, because over here I did the math for you, right? I did one of the 90, right? And I divided that out. Got to do a little bit of side math. Remember, you got to move that once. You got to move that once. Remember all that? So a great white shark can swim 36 feet in 1 second. You want to put that in perspective. This is why you can't swim away from them. You want to put it in perspective? That's almost exactly the length of this room in 1 second. That's a visual for you. No, I'm serious. I measured it. It's like 38 feet from that wall to that wall. So do you think you're going to outswim that? Yeah. No. Yeah. You'll be in his mouth before you know it. All right. Yeah, you won't be swimming. All right. Okay, so again, if we would tweak this problem just a little bit, so we could say, again, we're going to find rate, right? That's distance divided by time. Okay, I'm just tweaking this same thing. So let's say the shark can swim 60 feet in 1.25 seconds. And again, over here, you got to do a little bit of side math, right? You got to move the decimal 2 places, right? I'll do the math for you. You'll be doing it later. So now it's 48 feet every 1 second. Yowzer. So the key here when we're trying to find the rates is you have to have 2 labels in your answer because you're finding the rate. You got to have it. Distance, 1. What's the distance? Miles, feet, yards, inches, kilometers, whatever. Okay, when you're dealing with a rate, the good news is when you figure it out, the numbers are already there. You just got to put them in the right spot and divide correctly. Does that make sense? All right. One more. I think you'll like this. A lion runs 288 feet in 4 seconds. I know. You guys outswam the shark and you're going to outrun the lion. I know. So our rate here, the distance is 288 feet in 4 seconds. The time, and again, as we've talked about from day 1 of school, remember you got to know which one the divisor and which one the dividend is there. Got to get those in the right spot. So our rate, once we divided, is 72 feet per second. That's twice as long as this room in 1 second. You can run faster now? And if you didn't figure it out, I know some of you might be saying, well, I'll climb the tree. Don't forget that's a cat. He'll be climbing it with you. All right. Any questions about finding distance or finding rate? Distance, obviously, you're going to multiply, possibly cross reduce. When it comes to the rates, you're going to divide. Again, you got to know you're going to have to divide decimals like we did in chapter 3. You're going to have to remember to move the decimal to the right in the divisor and the dividend and make sure that you divide correctly. Anybody have any questions on solving rates? Okay, you don't have to memorize those 2 formulas, even though they're not that difficult. They will be provided for you, but if you want to memorize them, that would be fantastic. All right, if not, everybody's good. Okay, I think I put on there your homework today is 1 through 19. Now, this is where you got to show your work. because you got to set up the formula. You got to put the numbers in the formula. 1 through 19, and I believe you're only doing the odds even.